Hi everyone, welcome to Java Techie. In the last tutorial, we explored different propagation labels with hands-on examples, right? Now in this tutorial, we are taking things a step further. We'll dive deep into different isolation labels in Spring transaction and we'll understand what they are, why they matter, and how they ensure data consistency in real-world application. Okay? As always, we won't just stick to the theory. Rather, we'll break it down with practical examples and see each isolation label in action so that you can master this concept and apply them confidently in your real time project. Okay, all right. So, without any further delay, let's get started. So, first, let's understand what is isolation. In transaction, isolation controls the visibility of changes made by one transaction to other transaction. For example, there is two transaction T1 and T2. What T1 is doing, it should be updated to the T2. That is what the role of isolation to make the data consistency between multiple transaction. Okay, let me keep a note of it. So we understand at high level what is isolation, right? So don't worry, we'll demonstrate each and isolation with valid example. Now first let's go and check what are the different type of isolation available in transaction. So you can validate here, just add isolation, then go to the isolation enum. If you see here, there are total 5 isolation label: default, read uncommitted, read committed, repeatable read and serializable. So we'll do the postmortem of each and every isolation label here. Okay. So let's begin with the first one, that is default. So this default isolation label is specific to your database. So what database you are using and what is the default isolation label set to that database will be used if you will specify the isolation as a default. For example, let me go to my database. Now if I'll trigger the query here, so variable like, you can define transaction isolation. Okay. Now if we'll run it, okay, this is transaction. Can you see here what is the default isolation label configured in my database? That is repeatable read. Okay, so now if in my code, if I use the isolation as a default, it will by default take as a repeatable read. It will by default set the isolation label to repeatable read because that is what by default configure in my database. So you can override that, you can change it to read committed, read uncommitted, or serializable, that you can override using the query. We'll understand that in a moment. Okay, so if you are using default, you know what is the status, right? It will take any of the isolation label from down. That is what you will configure in your DV. So default, you can ignore it for now. Once you will understand these four, then you can set default and you can override the value in DV so that it will take that specific isolation label. Fine. So let's go to the next isolation label, that is read uncommitted. So I will tell you the problem statement using each and every isolation label. Then I will show you how you can solve it. That way you can understand the clear picture of when I should go for this type of isolation label. So let's begin with read uncommitted. Let's consider an use case, same inventory system. You have the product table with ID, name, price and stock value. Now what isolation we are going to discuss, that is read uncommitted. Okay. we are going to discuss about read uncommitted isolation. What do you mean by read uncommitted? We just want to validate if there is a transaction 1 and there is a transaction 2. If anything going change here, whether it is reflecting to the transaction 2 or not, or what value it is reflecting to the transaction 2. That is how you can validate the different isolation label. Okay, just ignore it. We'll go with the valid use case. Now imagine there is a transaction 1 and at the same time there is another transaction that is called transaction 2. What transaction 1 is doing, he is trying to update the stock value. Okay, he is trying to update the stock value. Let's consider this particular laptop product. However, currently the stock value is 20. This transaction 1 is trying to update the value to 10. Now at the same time, transaction 2 wants to read the stock value of that same product. Read stock. What value it will display to transaction 2? It will display 10. Think in real time perspective, is this behavior is correct? No, right? So what transaction 1 is doing here, he is trying to update the value. Does he committed the changes? No, he didn't commit the changes. It means transaction 2 is trying to read uncommitted data. What if in future or after some time transaction 1 will roll back the change? If you will roll back the change, it will be updated to the 20. But what this transaction 2 is getting the value? It is 10. It means the data is not consistency between these two transactions. If you will use isolation label read uncommitted, what transaction 1 is doing, that uncommitted value will also read by transaction 2, which will lead the data inconsistency issue in their application. Okay, so this is the simple use case to understand read uncommitted. If there are two transactions, one transaction is doing some update on the value, transaction 2 should not get the uncommitted data. That is what the read uncommitted. Okay, don't worry, I'll show you in the code and I'll also show you the console output by using this read uncommitted. If still you are not clear with this particular use case, let me give you one fun example. Okay, then you can relate what I was trying to convince. Now imagine, okay, let me go here. Now imagine you and your girlfriend want to watch some movie in this coming weekend. Okay, you both wants to watch some movies and think there are total 2 ticket is available in theater. Okay, total 2 movie ticket is available in the theater. Now there is a transaction 1, some guy, okay, Rahul, he is trying to book the ticket. Now there is another transaction 2, let it be, that is you and your girlfriend. Okay, now what Rahul is doing, Rahul is trying to book the ticket. He also need 2 ticket, so he is trying to book the 2 ticket. Okay, but he didn't pay, he didn't commit the changes, he didn't confirm the ticket booking. At the same time, when you and your girlfriend was searching for the ticket, you guys are getting 0. Okay, because he already took the 2 ticket but it is showing you 0, there is no ticket available. Now this Rahul, rust fellow, what he will do, after some time he got some different plan, he will roll back. Hey, I don't need ticket, I will just simply log out from my system. Now since you guys, when you search, you found the ticket availability is 0. Now after some time this guy released, but still it is 0 for you. In this case, what this transaction to you and your girlfriend get the result, since Rahul was trying to book the ticket but he didn't commit it or he didn't confirm the booking, still it is showing you, hey, there is no ticket for you. After some time he roll back, ticket is available but you already logged out. In that case, definitely there will be a big fight in your home in weekend, right? So what you understand here, transaction 1 did the changes but he didn't commit the changes. At the same time, transaction 2 was trying to read the same product, so it is showing uncommitted data to transaction 2. That is what the data inconsistency. So you can consider the movie ticket scenario, or you can consider update the product and read the stock or read the product stock at the same time. Okay, so we'll go with this particular example. You can try with this particular movie theater example. If you are feeling happy with this, go with it. Okay, both the way I'm trying to convince the isolation read uncommitted behavior. Fine. So let's try to reproduce this use case in action. Let's go to our IntelliJ idea. Let's create the project and do the magic. So let's create two method. Okay. One will update the stock. One will check the stock. So already I created this service. There is no rocket science. So if you see, this is the update stock method. We'll just get the existing product from the DV and update the stock value and save the product object to the DV. Okay, and then we have check stock, who is nothing, who will fetch the product object from the DV and return the available stock quantity. That is what I have created two different method to just simulate two different transaction. Okay, so let's consider this is a transaction A who will update the stock, and this is transaction B who will just check or fetch the stock. Okay, so if you see the code, what I am doing, after transaction A update the value, I was trying to sleep for some second to simulate transaction B to get a chance to execute. Okay, then that's it. Now let's create two different thread as a two different transaction. One will call this update stock and another one will call the check stock. Okay, then we'll see in read committed how it behaves. So for that, first you need to define transactional. What is the isolation we are going to discuss now? Isolation read uncommitted. Pasted here. Okay, we are trying to see the behavior in the read uncommitted. So whether we want to validate whether this check stock method is reading the committed data or uncommitted data, because that is what we have defined here. Now let's see the output, then we'll understand what we just discussed in a theory. Now let me create another package here. Now here I'll just add a class read uncommitted demo. I'll show you what I'm doing here. So see the method name test read uncommitted. I have created two different transactions by creating two different thread. This is a transaction A, which is nothing your thread 1. This is a transaction B, which is nothing your thread 2. Now what this guy is doing? This transaction 1 is trying to update the stock. So let's validate what is the value in DV now. It is 10, right? So let's update it to 20. Or let's make it 50, okay? So the stock value for laptop is 50 now. So what this guy is doing? This guy is trying to update the stock value to 5. Okay, but he didn't commit it. If you see here, he didn't commit it. After that, we just stop that thread for, or we just ask that thread to sleep for 5 seconds. At the same time, we initiate another thread which is nothing a transaction B. He will wait for 2 seconds and then he will just fetch the product. Okay, so he just need to wait a moment to ensure thread A start and hold the transaction. Okay, this is a simple use case, guys. Okay, so to just understand isolation, we need two different transactions who can run concurrently. So that is the reason I have created two different thread. Now let me define a controller and we'll access this and we'll see the result. So just go to the controller class. I'll just define here only some test isolation. So read uncommitted demo, right? Just use this, just inject it. Okay, So I'll just use read uncommitted demo dot test read uncommitted. Let me hard code it one. Okay, I mean, I just want to check for the laptop. I don't want to pass the value from here. Now why this is there is error, just throw the handle the exception. Okay, I'll just throw it for now. Just define get mapping and just define isolation. Now once I trigger, okay, return something, return. So once I trigger this particular endpoint, it will call this method, who will create two different transactions. One transaction will update the stock, another transaction will check the stock, and we have just play with some time to sleep the transaction one for some time, so that this will get chance. After this, we'll ask this guy to sleep for some time, so that transaction A will get some chance to execute. Okay, that is how we just play with the time. All good. Now before that, now what we understand here, what is the current default isolation set to my DV? It is set to repeatable read, but we are trying to demonstrate read uncommitted, right? So I need to update it to the read uncommitted. I need to set the transaction isolation label to read uncommitted. So this is the command. You can override the transaction isolation label in your DV. Okay, now I just update it. Now if I'll check the, now what is the value it is showing to me? Read uncommitted. We are good now. Let me restart the application. So application started here. Now just clear it. Go to the browser. Open Swagger. Try this particular endpoint. We'll validate through the console output. Okay, just execute it. Now read the output carefully. Okay, so see here. First transaction A update the stock to 5, which was 50. Transaction A was trying to update it to the 5. Now at the same time, transaction B read the stock as a 5. Okay, now tell me here, when transaction B was trying to read the value, does transaction A committed the changes? No, right? He just update, then we ask him to sleep for 5 seconds. Then immediately when transaction B get the chance and he read the value, he is getting 5. It means earlier it was 50. The value was updated by the transaction A, which is not committed, but transaction B was still able to read the uncommitted data. Can you see here? Same movie ticket scenario you can consider. There are 50 tickets available in the theater. Transaction A is nothing. Rahul was trying to book 45 ticket. Sorry, he was trying. Yeah, correct. He was trying to book 45 ticket. Now, at the same time, when transaction B, you or your family want to check the ticket status, you guys are getting only 5. Even though Rahul didn't commit those 45 ticket. Correct? This is something called uncommitted read or dirty read. Okay, if you see here, stock read by transaction B is this. After that, this guy committed. After transaction B get the value, this guy committed it to the DV. Now if you check in the DV, what is the value of product? The value is update now. Now let me update it to 50 again. What we'll do? We'll intentionally ask transaction A to roll back after read by transaction 2 or transaction B. Okay, so let's simulate that rollback scenario. Just go to your product service. Now here, after it sleep, you just simply roll back it. So just simply use transaction aspect support or something. Yeah, transaction aspect support dot current transaction status dot rollback. Set rollback only. Okay, currently we are explicitly doing the rollback. Fine. So I'll just add a statement here. Transaction A rolling back the update or something like that. just comment this for now. Fine. So let's restart the server. Then just clear this, go to the Swagger, trigger the request again. Now see the magic. What happened? Transaction A is trying to update the stock value to 5. Fine. Then at the same time, when transaction B was trying to read the value, he is reading the uncommitted changes. That is 5. Transaction B is 5. Now after some time, this transaction A rolling back the update. Same like Rahul. Okay. Now what is there in DV? If we'll validate in the DV, it is 50. But what this guy is saying, this transaction B 5, because at the same time both transaction was playing with the same data. However, transaction B was only reading the uncommitted data, even though that 50 stock is back to the inventory store, but still it was 5 for transaction B at the time when he was reading, or at the time when he was fetching the stock value. Okay, so this is called dirty read or uncommitted read. Now what I want to do, I don't want to read the uncommitted data, I want to read only the committed data. For example, if you'll understand the same use case, here we have two transactions, transaction 1 and transaction 2, right? Transaction 1, let's say the value was 20. Transaction 1, I will create another transaction here. Transaction 1 is trying to update it to the 10. Transaction 2 at the same time is trying to read it. So rather than showing the uncommitted value to transaction 2, he should read the committed data, because transaction 1 is trying to update it to the 10, but he didn't commit it. Okay, he didn't commit. Until unless transaction 1 commit the changes, transaction 2 should get the committed data only, which is nothing 20. Okay, so how you can achieve that? That is what our next isolation label, to read the or to avoid the dirty read and only read the committed data. Okay, so what I'll do, let's go to the isolation. We are done with this read uncommitted. Okay, we understand the problem using read on uncommitted, which is nothing, it allow dirty reads which create the data inconsistency throughout my application during the transaction. Okay, to avoid that, what we can use, we can use the read committed. This is the second isolation we are going to discuss now. Fine. So what I will do for that, I'll just revert this rollback changes. Fine. I'll just revert this two line, or I'll just comment it. Now this update stock, I want it to be run on the read committed isolation label, so that I can only read the committed value. Read committed. Okay, so I will just use the same code. Let's use the same. Yeah, so better I'll change it to some different name, or you can duplicate it. Better let me duplicate it. Okay, same code only, I'm just trying to add different demo, so that it will be clean for you to understand. Same changes, there is no other things added here. Fine. So let me inject this read committed demo in my controller, then we'll understand the flow. So you can use the same endpoint. I'll just comment this read committed demo. Okay, dot test read committed, pass the id as 1. Fine. See here, there is no rocket science. Again, I am creating two different transaction, transaction 1 and transaction 2. One will update the stock, one will fetch the stock. So currently, let me update the stock value. What is the value now? 50, right? Let it be. Now let me give you some advanced hints about the console output, so that you can relate. Okay, read committed will not allow any dirty read or any uncommitted read. So here, what is the value? Stock price 50 for laptop, right? Because that is what the ID we are giving here in the controller class. Fine. So just go to the read uncommit, not this one, committed demo. What this guy will do? This guy will try to update that value. Earlier it was 50. This guy will try to update it to the 5. Okay. Now at the same time, when transaction B will try to read the value, what should the value display to transaction B? Since we are asking both the transaction to use only read committed data, here transaction B should read the value as a 50, because there is no guarantee, right? What is the thread A is updating the value, he will commit it. What if he roll back the changes, right? So I don't want to go into that mess. Rather give me the clean value which was last committed earlier. Give me only the committed value. I don't want to see any uncommitted value, or I don't want to deal with any dirty value. Okay. So here you will get the output as a 50. Let's run the code and we'll validate the result. But before that, go and check in your DV what is the current transaction isolation label, that is set to read uncommitted, right? Just override it to read committed. This is not mandatory step what I am doing here, but sometimes since I am using the MySQL, it will behave differently based on the engine what you are using. So if you see here, the product table I am using InnoDB. Sometimes it will force you to use my ISAMDB for some different isolation behavior. Okay, again, no need to go in details about it. If you have PostgreSQL, you can happily play with all different type of isolation. But if you have MySQL, for safer side, just override the isolation label what you want to test. It's just 1 second task, right? Okay. Now if I will search, not this one, if I'll search the isolation label, it's now read committed. So just restart the server. So it started. Just clear it. Go to the Swagger. Just trigger the request. Go and check the output in your console now. Okay. Can you see here from where it started here, right? What is the earlier price of the stock where the product ID is 1? It is 50. Transaction A is trying to update the stock value to what? 5. He is trying to update, but he didn't commit it. At the same time, we allow transaction B to get the task done. I mean, we just ask transaction A to sleep for 5 seconds. So same time, transaction B get a chance. He was trying to read the stock value. He is getting 50. That is correct, right? This is not uncommitted data. This is the last committed value, because there is no guarantee whether transaction 1 will really update it or he will roll back it. So I don't want to go with that mess. Better give me the last committed value. Fine. You can relate the same use case to the movie theater example as well. Okay. Now transaction B read 50. Later he committed the update. Now if you will check in the DV, what is the value? 5. Let it be, because I was not sure whether transaction A will update the value or he will roll back. The time when I was fetching the things, it should give me the last committed value. So I only want to read committed data. This way you can avoid dirty read. Okay. So if you'll go here isolation, we understand using read uncommitted allow us to read dirty content or uncommitted data. However, you can avoid that or eliminate that using read committed. But again, there is a problem in read committed. Now, what happened? Let me tell you. So, let's say, let me open the new page. Now, imagine again same product table where the initial value was 50, the stock value for laptop, that is the ID 1, right? Now this is transaction 1, this is transaction 2, transaction 1 and 2. Now what transaction 1 does, he update the stock value. Update the stock value to 10. But transaction 2, when I will use the read committed, when it will read, it will fetch the value as a, what is that, 50, because that is the last committed value. We are not sure whether this will getting update or it will simply roll back in some time. We are not sure about this behavior. So when transaction 2 read the value, he will get the last committed value. Now imagine this value is update in the DV. But again, still this is not committed yet. Okay, this is not committed yet. Now again, this guy transaction 2 will try to read the value, he will not get 50. Rather, he will get the value 10. So what I want here, I want to maintain the consistency before transaction update and after transaction update. How many times I will fetch the value? I need the consistent result. I don't want any inconsistency while processing or while reading when the transaction is active. Okay, so in that case, to avoid this kind of issue, you can use repeatable read isolation label. Okay, repeatable read. Okay, what this repeatable read isolation label does, it ensures that if a transaction reads the same data multiple times, it will see the same data throughout the transaction, even if other transaction modify the data. This way it will prevent the dirty read and non-repeatable read. But again, it does not what I can say, it does not prevent the phantom read. I will come in a moment. I will explain in a moment about the phantom read. Okay, this way you will avoid the dirty reads, which is nothing your uncommitted read, and non-repeatable read also you can avoid if you are using repeatable read isolation label, because I want the consistency value. Okay, now let's understand the same use case in action. Just go to the code. Now what this guy is doing, transaction 1 update the stock, that is correct, that is the expected, because if you understand here, transaction 1 update the stock. However, this transaction 2 is trying to read multiple times. Okay, so let's create or let's read multiple times in check stock. Better, I'll create another method called fetch stock, who will read the stock multiple times. While you'll read multiple times, you should get the consistent result. So what I'm doing here, this is the product 1 which I am fetching from the DV. So I added the meaningful messages, transaction B fast read and the quantity what is the available. Then we wait for 3 seconds, we simulate the delay to allow transaction A to update the stock. That is what I explain here, right? Before and after update the value should be same. I want 50 here. Before update and after update also I should get the same result. Okay, so that is what I am doing here. Fetch the first product, then wait for 3 seconds, let transaction A to execute. Then immediately I have the second time I am fetching the same product and I am printing what is the value I am getting. Okay, so let's say, let's change some different number. Okay, let's keep it 40. Now if you check the product, what is the value? 40, right? Now here, what we are expecting here, this guy, this update stock, this particular method will update the value to 5. However, the initial stock is 40, right? So in the fetch stock, at the first read, I want the value to be display constant 40. Then in second read, also I want to see the value as a 40. I don't care if any transaction is doing any modification in between, since my transaction is active. How many times I will fetch the result, I will get the constant output. Okay, that is what all about repeatable read. So I will also change the isolation label to repeatable read here. All good. Now again I will create another demo class to simulate the repeatable read. Let me duplicate this. Okay, just go here and paste it. Same thing here. Transaction A will update the things. Transaction B will read the value. Okay. While read, we have mentioned to read it twice. This will be before any update by transaction 1. This will be after update by transaction 1. Transaction 1 means transaction A. Okay. Now let's run it and we'll validate. Before that, just use this class and inject it in your controller class. Just comment it and then use repeatable read demo dot demonstrate repeatable read, give the product id 1. Okay, once again just cross validate. What is the product details? This particular laptop, the quantity is 40. Now what is the current isolation label set in my dv? It is read committed. What I want to keep it read repeatable, right? So let me change it. Just let me copy the proper name. Okay, repeatable. What is the error? Repeatable. Okay, this should be repeatable read, not read repeatable. Fine. Now if we'll check the isolation label set in your dv is repeatable read. Well and good. Now let's restart the server. So it started. Just clear this. Now go to the Swagger and trigger the request. Now if we'll check the output. Okay, what is the first? Where it went? Yeah. So first transaction B get a chance to execute. That is nothing thread 2. So he read the value first 40. That is what they are in our DV. Then transaction A get a chance and you update the value to 5. Then after update, see this. This is before update and this is after update. What is the value? Is this constant or not? Transaction B first read is 40. Transaction B second read is also 40. And in between that, this guy is updating the value. So transaction B no need to care about it. I want the constant before and after update the things. That is what I am getting here. This way you can avoid the repeatable read. Okay, that is, see what things you can avoid. For that solution the isolation label name is there. So I don't think it will complex for you to remember what repeatable read does. It will avoid repeatable read. That is the first statement. Now while explaining this you should understand, okay, what do you mean by repeatable read? Okay, that is how you can understand the thing. So fine, the first before update the value was 40. Let this guy update, I don't care about it. After update when I see the value it is 40. And if you, I didn't walk through this statement in this isolation example because already I explained in the propagation, right? How it create the new transaction, how it reuse the transaction. So you can validate that. We are good till this point, right? We are done with the repeatable read. Now let's move to the last one, that is serializable. This is very interesting properties as part of isolation. So if you are using serializable isolation label, then it ensures that transactions are executed in a manner equivalent to running them sequentially one after another, even if they are executed concurrently. Okay, now for example, now here we have two transactions, right? One is doing modification and other one is getting issue. Now what this serializable does, this transaction, this isolation, what it does, you have transaction 1, you have transaction 2. Okay, this guy is trying to update, this guy is trying to read. Now what it does, once transaction 1 started At the same time, if you'll start the transaction 2, even though both are executing concurrently, it will apply the lock. Serializable isolation will apply the lock. First, let this guy to complete the task, then only it will give chance to execute your transaction 2. There will be no concurrent execution. It will be kind of synchronous execution one after another. One transaction complete their job, then only the serializable will release the lock to transaction 2 to execute the task. Okay, both can run parallelly. In this way, the movie theater seat booking ticket issue will be completely resolved. Okay, I don't know, I'm just giving the hints. You need to find out and answer me in real time while booking the flight ticket or while booking the movie ticket, which isolation label is the appropriate solution for it. Okay, what I should use in real time. So you need to answer me in a comment. Fine, let's understand how this serializable isolation will execute one after another, whether it is really maintain the synchronous, or if you run in concurrent way it will break. Let's validate that. Okay, so just go here, and what I will do, I will just go to the product service. I will just change it to serializable. Check stock. Now nothing to do. Let it be. This we are not going to use now. I mean, this is just to do the repeatable read validation. So what we can do? Let me duplicate this. Okay. Then we will just add another one for serializable demo. So I have just created different demo class, but if you check the code, there is no change in this particular class. At the end, our ultimate goal to spin up two thread to just simulate two transaction use case. So that is what I am doing in all these four class, but I just segregate it for better visibility. Fine. So nothing again, transaction A or transaction 1 will update the stock. This guy will read the stock. That's it. Okay, so I am forcefully trying to sleep so that we can validate. Okay, one thread first get the chance. Let's see that. Okay, so nothing to do, let me copy this class name, just go to your controller class. I need to inject it. All good. Now just call the method, just comment this. So let's do one thing, let me disable this log. Okay, otherwise we need to read so many logs, so better let me comment this. So all good, let me restart the app. Here what we should observe, first let me change some other value. Let's keep it 20. Okay, so here the expectation is very simple. I want, even though we have started two transactions concurrently, both can't run parallelly. Rather, serializable will force those transactions to run one by one. Let's see the order. Okay, but before that let me check what is the isolation. We have repeatable read, right? We need to change it to the serializable. Now if we'll check the isolation, what is the value? It is serializable. All good to go. Now just go to the swagger, just execute the request. So if you'll go and check the console output, yeah, see the magic. Transaction A execute first, it stock the update. Okay, then it print the messages. After this transaction A execute, it started executing the transaction B. See the order, A first, then B. Can you see here? Now there is no data inconsistency issue. Transaction A execute first, it update the stock and commit the value. Hence, at the same time when the transaction B will try to fetch the record, stock quantity is reflecting correctly. Can you see here? This way, if you are using serializable, it will always guarantee there will be no dirty read, no phantom read, okay, no repeatable read. But since the flow is going to be synchronous, it will lead the performance issue. So if you want to play with huge data, it's not recommended to play with the serializable, because it will apply the locking mechanism which will slow down your performance. But again, we cannot say it's not recommended. It is highly recommended in real time project. Okay, so you need to figure out when to use it. So I already give you the clue when to use each and every isolation label. So to just brush up the things what we have discussed, let me summarize all the isolation label. So if you see this, I cannot zoom this because the image is not clear. Anyway, it's fine, right? It's visible, I believe. Now, read uncommitted. What it avoids? Nothing. We found the dirty reads, read uncommitted data, which we discussed. Okay. Now, read committed. What it avoids? It avoids dirty reads. Okay. See only committed data. That is what also we validate. Now, repeatable read. What it avoid? It avoid dirty reads, non-repeatable reads. Ensure consistent read in one transaction. We try to read multiple times, but we get the correct value. Between that, other transaction when they are trying to update the value, still it don't impact anything to us. Okay. Now the last one which we just discussed, that is serializable. What it avoid? It avoid everything. It avoid dirty read, non-repeatable read, and phantom read, fully isolated transactions. So in real time, it's recommended to use read committed, repeatable read, and serializable. Okay, so I believe we are under same page. If yes, then given a scenario, you should be in a state to figure out what isolation level I need to use in this case, or what is the propagation level I need to use. You should be in a state to figure it out. So try playing with different isolation and propagation level, and do let me know in a comment section if you have any doubts.
That's all about this particular video, guys. Thanks for watching this video. Meet you soon with a new concept.